This is Ton van Voorden, your statistics teacher. And in this lecture I'm going to explain to you what is a discrete probability distribution function. So like denoted by PDF probability distribution function. As an example, you have a dice, you throw a dice. If you throw a dice, you can throw a 1, a 2, a 3, a 4, a 5 and a 6. And if the dice is normal, the probabilities are the same. So in total you have the chance of 100%. Denoted in probabilities. Probability, really important, probability is percentage divided by 100. So the probability that you just have one outcome is always 1. Probability, an outcome equals 1. So if you throw up a coin, you can have tail or you can have head. The probability that you have tail is 50%, or denoted by probability, the percentage chance is 50%, and if you divide it by 100, the probability is 0.5 for tail and 0.5 for head, so together they are 1. Going back to our dice example, if you have your dice, you will see that the total probability will be 1, so you have 6 different outcomes, and all outcomes will have the probability of 1/6 that they occur. So I can make like little lines on top of it till the 1/6. Why here's nothing, it's like impossible to throw a 3.5 with a dice. So the probability of throwing 3.5 is 0. Therefore you can throw 3, but you cannot throw 3.1. As opposite to a continuous probability distribution function, for example waiting time for a bus, every 5 minutes there will be a bus. Then you can have to wait 1 minute, you can have to wait 0 minutes, the bus there directly, you can have to wait 2, 3 or 4 minutes, but you can also have to wait 2.5 minutes or like 2.999 minutes. So everything is possible, and then you will write it down like this. But more than 5 minutes is like not possible, because every 5 minutes there will be a bus. So then you just didn't go inside the bus, but actually you didn't need to wait longer. You can also not wait shorter than 0 minutes, so then it goes like here. I will explain you later more about continuous distribution function, but I want to show you the difference between what is a continuous distribution function and what is exactly a discrete distribution function. Discrete, continuous. How you can write it down, the discrete distribution functions. A lot of time you see them in a table. You see like the outcome 1, 2, 3, 4, 5, 6, and below the probability 1/6 for all. And what's important, if you sum up all these possibilities, you always get to 1, and 1 times 100 is 100%. So there will always be an outcome. It could be a positive outcome, a negative, but if you have always all the outcomes together, it will be 100%. Notice I wrote down here 4 different things, because in different studies it's denoted in a different way. Some studies it just say PDF, other studies it say f, the function of x, in which the function of x will be exactly the same as the probability. So notice if you see fx, then just notice its probability. Sometimes it's denoted as the p, x is ... So the p stands for, again, for probability that the outcome x equals 1, 2, 3, 4, 5, 6. What's also important is there's the probability distribution function, but there's also the cumulative distribution function, denoted as the capital F x, or denoted as the chance, probability, that x is smaller equal than a number. Like throwing a 1 or lower with the dice, you can only throw a 1. So 1 or lower will be exactly 1/6. But a 2 or lower, hey, now you can throw 1 or 2. So it will be 2/6. A 3 or lower, hey, you can throw 1, 2 or 3. So 3/6. Of course, it's the same as half. And you can continue it. And notice at the last, it's like the summation of all the possibilities. So this will always be a 1. Notice, if this is not a 1, you did something wrong if the last number is not a 1.